Alright, so in this video we're going to learn about how similar figures can be represented on the coordinate plane. And when we have similar figures drawn on a coordinate plane, we call them dilations. Alright? So similar figures, just a quick review, similar figures have the same shape, and they also have a different size. So what I have here is a first star drawn, and we can see that it's a little bit bigger than the second star that we have drawn. Given the side length 8, when I compare that to 4, I can see that our star has been reduced. And since 8 starts out for a pre-image and goes to a 4, we can see that it's been reduced by a scale factor of 1/2. Okay? Now, quick vocab. This shape is called a pre-image. Pre, because it's the shape before we make a change somehow. All right? So once we take this shape, our pre-image, we can multiply it by a scale factor of 1/2. And when we take half of 8, that's how we get this side length 4. Okay? Now we could start small. Our pre-image here could start small and then be enlarged for our image. All right? Now when we take a look at triangle ABC and compare it to triangle DEF, what we can do is take this side length and this side length, since they're corresponding, and we can see that the scale factor is in fact 2. We can see that our new shape is twice as large. Okay? So that being said, what we did in our last unit was we said, well, if 2 goes with 4, then x and 2.8 go together, and we can cross multiply and divide. Okay? Now a lot of people can simply multiply 2.8 times 2 and get that this value would be a 5.6, and that would be the missing value of x. So we've done a lot with similar figures. We've been able to find missing sides. We can see if it starts small and gets larger, it's called an enlargement. We also know that if it starts a little bit bigger and then gets smaller, it has been reduced. Okay? So we have reductions and enlargements. And one final thing I wanted to review was this thing called a similarity statement. And what the similarity statement does is it allows you to find out which sides correspond and which angles correspond. So triangle ABC is similar to triangle DEF. That lets us know angle A corresponds to angle D, angle B corresponds to angle E, and angle C corresponds to angle F. All right? So what if we know the coordinates of a triangle and the dilation scale factor? How do we know where to graph the image? What I mean by that is, let's say you have this triangle and you want to double it. Where would you graph this triangle on the coordinate plane? That's what we're going to learn now in our notes. Okay? So in your notes with me, you should be on page 1 of the notes. So let me go over. All right. Here we go. Page 1 of our notes. So a dilation of a geometric figure is a transformation that is going to change the size of the figure using a scale factor to create a similar figure. Our sides will remain proportional. I'm going to go over that in a second. All right? Up top, we've got that a scale factor is written as a fraction. And if the scale factor is less than 1, the figure is going to be reduced. Kind of like what we just saw with the star. If our scale factor here is less than 1, we know we're going to be reducing our pre-image. And if our scale factor is bigger than 1, we know we're going to enlarge our pre-image. Okay, so that's what it says up there in green. Now what I'm going to do is I am going to be reviewing right here how to find the new points. I'm going to come back and kind of sum up with that step. But notice what I have here is the same triangle from the other slide. And instead of calling it triangle A, B, C, I've simply called it triangle NFU. Okay? Now in the problem you'll see that it's labeled triangle FUN, and that's okay, it doesn't matter. What we've been given though is the coordinates for the points. And so if you guys will just take a quick second, you'll notice if I move over 3 and up 3, there's point F. If I move over 3 and up 1, there's U. And over 1, up 3, and I now have my triangle graphed on the coordinate plane. Using the grid in the background, I can count that side length is 2 and that side length is 2. So I've simply drawn the triangle over here. And now let's talk about the scale factor given as a percent. 200%, if we convert it, it's just 2 wholes. So our scale factor here, folks, is really 2. What we want to do then is double our dimensions, and so this will now be a 4 by 4. So we know how to create a similar figure, and we know how to enlarge it. Now the question becomes, where do we put this on the coordinate plane? Okay? So all I'm going to do is point out, we were given right here pre-image points for point F, U, and N. We also know that the scale factor is 2. So what we want to do is we want to double coordinate 3, 3. If you multiply 3 by 2, we get 6. Multiply 3 by 2, you get 6. All right? Now we're going to multiply the coordinates of this point by 2. So 3 times 2 is 6. 1 times 2 is 2. And last but not least, 1 times 2, 2. And 3 times 2, 6. So now we have all of the points in blue to graph on the coordinate plane. If I come over here, 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, 6, there's a point. And just so this doesn't get too messy, I'm going to erase those little dots. All right? I'm going to label that point F prime. And I'm going to come back and talk to you guys about what I said prime. I'm going to talk to you guys about that in a second. All right, now I'm plotting U prime. I'm going to move over 6, up 2. There's U prime. And last but not least for N, I'm going to move over 2, up 6. And there is N prime. So now we have our new enlarged triangle, and we can count this side. It is in fact 4 units long. And we can count here this side. It is in fact 4 units long. So we know we've successfully graphed our enlarged triangle in the right spot on the coordinate plane. Okay? So I'm going to erase everything here just so you can kind of see what to do from the top. All right? Just give me a second to erase this all. So here we are from the top. All right. From the top, we've got a triangle on the coordinate plane. What type of triangle do we have? Well, first, based on the angle right there, we can see that this is, in fact, a right triangle. Okay, that's a right angle right there. Now, based on the side length, that this is a 2 and this is a 2, we know that those two side lengths are the same. So we've got an isosceles triangle. And now all we're going to do is take our isosceles triangle, and since the scale factor is 2, we have an enlargement. And all we're going to do now is take each one of these coordinates and double them. So that's where I got this 6, 6. That's where I got 6, 2. And this is where I get 2, 6. I literally just multiply everything here by 2. And then we can come back over here on the coordinate plane and plot those points. So 6, 6 was here. 6, 2 is here. And 2, 6 was here. And now we've got the new right triangle graphed. And now for the notation. N, F, and U let you know you've got the pre-image. Okay. And now these prime points, it almost looks like a little apostrophe afterwards. That lets you know this is the new shape after the change. So now what I'm going to do is just simply label them F prime, U prime, and N prime. And we can see that this one came first, and this is the pre-image. And now this is the new shape after we've had a scale factor of 2. All right? Now let's take a look at the next one. All right, now let's take a look again down below here at what type of triangles we have here. Now I have measured this out just so you can see on the coordinate plane. And the dimensions are an 8.9 by a 13.4 and a 16.1 here. So since none of those sides are the same, we know we've got a scalene triangle. And we have 1, 2, 3 little acute angles. So it's an acute scalene triangle that we have for our pre-image. That's our pre-image. And now what the problem is asking us to do, dilate it by a scale factor of 1/2. We want to dilate triangle CAT using a scale factor of 1/2. So all we're going to do now is come through and take 1/2 of each one of these. So 1/2 of -6 is -3, and 1/2 of -4 is -2. 1/2 of 0 is still 0. 1/2 of 8 is 4. 1/2 of 2 is 1, and 1/2 of -8 is -4. So now we have our prime points for our new shape after it's been reduced by 1/2. And in blue, I'm going to plot them now. We go back 3, up 2. That's C prime. 0, 4. So 0, then straight up. 1, 2, 3, 4 is right here. There's A prime. And T prime, if you move over 1, down 1, 2, 3, 4, there's T prime. And when we connect, well, that doesn't look right. What did I do? Oh, I see what I did wrong. For C prime, you probably got wondering what I was doing just a second ago. That's back 3, then we got to go down 2. There we go. There's C prime. My apologies. And now we can see that C prime, A prime, T prime, our new shape, is half the size. And I have taken the time to cut all those numbers in half for you guys, and those would be the dimensions of every number cut in half. So over here, this was what we did in our last unit, and now all we're doing is simply putting it in the correct spot on the coordinate plane. All right? So on our next page here, now what we have is triangle DOG. There's vertex D is at 3, 3. So you guys can write that down. O is at 6, 3. And G is at 0, 6. All right? So now what we're going to do is we're going to take 1/3 of each of these dimensions by simply dividing by 3. So 3 divided by 3 is 1. 3 divided by 3 is 1 again. If we take 1/3 of 6, we got 2. 1/3 of 3 is 1. 1/3 of 0 is still 0. And 1/3 of 6, that's a 6. 1/3 of 6 is 2. So this is the image that we can now plot using our prime points. We're going to move over 1, up 1. Over 2, up 1. And 0, 2. And that was G prime, D prime, O prime. Whoops, messed that one up again. Sorry about that. So 1, 1 is right here. 2, 1 is right here. And 0, 2 is here. Here we go. And for this one of the only ways we can really check by verifying is that side DO is currently 3 units long, and D prime O prime is 1 unit long, and that does check out that it's 1/3 the size. Okay? So here we can in fact see that we have a reduction with a scale factor of 1/3. Now for our last question here, we have a quadrilateral. In the quadrilateral, MATH, the vertices were given right here. So if we move back to back to down 4, that's M. Back to up 4 is A. Back over to up 4, positive, positive is T. And then over to down 4 for the last point would be H. And that is our pre-image. Okay, that's the pre-image. So again, those points, if you guys want to jot these down, we've got 2, 4, and 2, negative 4 for H. We now have a scale factor of 150%. Now 150% is 1.5, and 1 1/2 as a scale factor, you might see 3/2 as the fraction. Okay. Now in general, that value is bigger than 1, so we are expecting an enlargement. And so all we have to do now is take each of these pre-image points and multiply them all by 1.5. Okay? So in your calculators, that 2, if we make it negative, and now multiply by 1.5, we're going to get a negative 3. Now let's take the negative 4, same thing, and multiply by 1.5, and we're going to get a negative 6. Now since I just did the negative 2 times 1.5, there it is again. And positive 2 would just be the positive version, so we're good to go there. With the negative 4 times 1.5, I got negative 6, so here it is again. And I know that 4 is going to be just the positive version of that. So now we have all of our points. We're going to move back 3, down 6. There is M prime. If we move back 3 and up 6, there's A prime. We're going to move over 3, up 6, T prime, and over 3, down 6, H prime. All right. So to check, let's take the pre-image right here. You guys see how that is currently 4 across? Well, what is 4 times our scale factor of 1.5? Well, that equals 6. So now let's check to see if up top here, this is 6 units long. And what do you know? It is. So we know these are all the right coordinates for this scale factor to be 1.5 times bigger. Now let's kind of we're going to use this same red pre-image. We're going to use the same pre-image here, okay? Same red pre-image. But instead of enlarging it, I'm going to suggest that it had been reduced by a scale factor of 1/4. My first question then is, how long would side A prime T prime be? Okay? How long would side A prime T prime be? Well, A T is currently those 4 units long. So now we're going to multiply by 1/4, and we're going to see that A prime T prime, 1/4 of that would really just be 1 unit long. Okay? Now, how long would side T prime H prime be if we had a scale factor of 1/4 and side TH is currently right here? Side TH is currently 8 units long. If it's currently 8 units and we took 1/4 of that, T prime H prime would be 2 units long. So now what I'm going to do in purple, let's just take 1/4. If the scale factor is 1/4, let's just make sure we got these answers right. Our original coordinates were -2, -4, -2, 4. 2, 4, and 2, -4. This was for M, A, T, H. The first thing we're going to double check is side A prime, T prime. That was from here to here. Now originally, we saw that that was 4 units long. And now what we're going to do is take a fourth of each of these and see what the new coordinates would be. All right, so let's take -2 and find a fourth of that. So we're at -1/2. And a fourth of 4 is 1. A fourth of 2 would be a positive 0.5. Again, 2 times a fourth is 2/4, which is 1/2. Okay, and that's just 0.5. And now let's take a fourth of 4. A fourth of 4 is 1. So now we have A prime to T prime. And all we want to do is check to see if A prime to T prime, if that is 1 unit long. Okay? So I'm going to graph in green. I'm going to move back 1/2 and up 1. Now I'm going to move over 1/2 and up 1. And that is, in fact, 1 unit long. So I just wanted to check down here that we were right with our prediction that this was going to be 1 unit long, and we were right. I simply took all of our pre-image points right here, multiplied by the scale factor of a fourth, and replotted A prime and T prime. And then when I connected from A prime to T prime, I can see that it is in fact 1 unit long. So we are done now with taking notes on how to either enlarge or reduce a pre-image. And now if you guys will flip over, let's take a look at the first 2 questions together. For the first question at the top, it says, if the scale factor of a dilation is 5, is that going to be an enlargement or a reduction? Well, if you multiply everything in a figure by 5, it's going to get 5 times bigger, so that's an enlargement. The next question asks, if the dilation scale factor is 1/5, do you have an enlargement or a reduction? Well, if you take everything and divide it by 5, if it's a fifth is big, it's going to get much smaller, so that's a reduction. And once again, with these dilations, we're dealing with similar figures. Now, what if, right here, you just have a scale factor of 1? Meaning you multiply everything, all the dimensions, by 1. Well, nothing changes. You're going to make a congruent figure. Congruent figures mean everything's the exact same. Similar figures means that you're going to have the same shape, but not the same size. One's going to be bigger or smaller. All right? So now let's take a look at problems 3 through 5 together. And problems 3 through 5 use this red rectangle, which is already graphed on the coordinate plane. Okay? So let's take a look. We're going to start now with question 3. It asks, what are the coordinates of the vertices that correspond to rectangle ABCD after a dilation with a scale factor of 1/3? This scale factor of 1/3 already lets you know that everything's getting smaller, it's being reduced. So all we have to do is take point A and divide by 3. So let's take a look first at point A. A is currently at -6, 6. And if we divide both of those by 3, A prime would be at -2, 2. If I'm looking here at A prime, I can already see right there, that's the only one that has A prime. 1/3 of it would be -2, 2. All right? Now to check, I'm just going to use point C real quick. C is currently 3, 3. So then C prime, if we want 1/3 of that, it'd be at 1, 1. And C prime right there checks out, so we know the correct answer here is B. All right? Now I'm going to erase all of that, just so we can take a look at question 4. All right, now we're on question 4. This time it asks, what are the coordinates of the vertices that correspond to A, B, C, D if we dilate with a scale factor this time of a half? So this time we only want to worry about taking half of our numbers. So once again, I'll start with point A. A is currently at negative 6, 6. And now if we take a half of that, A prime is going to be at negative 3, 3. So over here, all I'm doing is looking at A primes, and I'm looking for which one is going to be at negative 3, 3. And I can see it right here for J. All right? Now I do want to talk about this fraction in here, just so that we're on the safe side. Let's focus in on point B. B is 3, 6. And once again, we want to cut both of those in half. And 3 halves is 1.5. And 6 divided by 2 is 3. So those both check out. All right. Now I'm going to erase this stuff and focus in on question 5. Okay? So for question 5, what it's asking, if the coordinates of point A after a dilation are negative 4, 4. So I'm going to read that one more time. The coordinates of point A after a dilation. After a dilation is the image, y'all. So that's going to be right here. That is A prime. It is telling us what it's going to be. It's telling us that A prime is going to be graphed back 4, up 4, right here. It's telling us A is going to go from here to here. And it's asking then, what is the scale factor? Now we know in red, we have the pre-image shape, negative 6, 6. And once again, we know the points are going to go to negative 4, 4. So in green, what I'm asking here is, what is our scale factor? What do we need to multiply that 6 by to get the 4? If we're trying to go from this 6 to this 4, what do we do? So I have an unknown x, and it's multiplied by 6 to equal 4. So to solve, all we do is divide both sides. And we're going to get that x is 4, 6. Now we can reduce 4, 6. 4, 6 does in fact reduce to 2/3. So our scale factor here has to be 2/3. We take 2/3 of every one of these big points, and when we do that, we're going to get a smaller rectangle. Okay? Now I have worked through examples 3, 4, and 5 with you guys, and now I want you to try 5, 6, and 7 on your own. If you need to take just a minute to pause the video, just pause the video and try on your own, and then when you hit play, I'm going to go over questions 6, 7, and 8. So now that you've tried questions 6, 7, and 8, let's take a look at number 6. All you have to do is take each of these pre-image points over here and multiply them all by a 2.5 to figure out which one of these is the correct set of points for our image. Now I'm going to just randomly pick point C to check. I'm going to take C, 3, negative 3, and I'm going to multiply both of those by 2.5. It is okay to use your calculator for this. So 3 times my scale factor of 2.5 would be 7.5. And then obviously if I did times the negative 3, I'm going to get a negative 7.5. So C prime would be 7.5, negative 7.5. That would be C prime. So that's knocked out, that's knocked out. This shows positive then negative. This has negative then positive, so that's knocked out. So it's got to be H. All right, for number 7, all you have to do is take the pre-image and multiply by 0.6. So since I started with C, let's keep with C. C for the preimage is 3, negative 3. And now all I'm going to do in the calculator is multiply it by 0.6. All right. So the positive version, whoops, not 0.06, just 0.6. We get 1.8, and then it'll be a negative 1.8. So we get 1.8, and then we get a negative 1.8. So C prime, 1.8, negative 1.8. That narrows it down. Looks like we're going to have to do another one now. Let's take a look at A. A was originally back 4, up 3. So now let's multiply by 0.6 to get A prime. All right, so in the calculator, negative 4 times 0.6. All right, negative 2.4. And now 3 times 0.6 we already did right here. That's the 1.8. So now for A prime, we're looking for negative 2.4, 1.8. So between these two, there it is, which means C is the correct answer. And now we're on the last one here for number 8. If the coordinates of point D prime after a dilation are negative 2, negative 2, what's the scale factor? All right? So in red, all we have is the pre-image, the fact that point D started out at negative 3, negative 3. It's right there. All right? And it tells us if we dilate it by an unknown scale factor, we don't know that yet, it's going to go to negative 2, negative 2, which would be right here. So our values went from a negative 3 to a negative 2, and I just do not know what I needed to multiply by to get that. So x is our unknown right here. It gets multiplied by negative 3 to equal negative 2. So if I simply divide both sides, a negative divided by a negative is a positive. And we can see that our scale factor must be 2/3. To check, what we're saying is if a point started out at negative 3, and had a scale factor of 2/3, is it at negative 2, negative 2? So we will take negative 3 and multiply it by 2/3. So 3, when you divide it by 3, we get negative 1. Now that times 2, negative 1 times 2 is negative 2. So that would in fact be our new point, negative 2, negative 2. If it started out at negative 3, and had a scale factor of 2/3, we'd be right there. All right, and now let's flip over to the, so y'all have to flip over. You're right there. All right, so we have a pentagon here, and there are 5 points. And what you're going to do now to practice is answer questions 9, 10, 11, and 12. And we will be going over these together as a class. Thank you for your attention.